Hey guys, I'm going to take you through the guided practice over the PVnT charts. Feel free, you guys can skip ahead to any ones that you may have had trouble with, but I'm going to go through each one and explain. You could also just kind of skip ahead if you want to check your answers for certain ones as well. Alright, so for the first one, what would be the pressure if 250 milliliters of gas at standard pressure is compressed to 150 milliliters? So first thing with this, you can go ahead and fill out your chart with what you do know. So we know the initial and we know the final volume of the container. The other thing it tells us is standard pressure. So remember, this is up in the notes and it is 1 atmosphere. So we can put that here as well. And if you go back to the question, it's asking what would be the pressure. So I'm going to put a question mark here in our final. You can go ahead and cross these out as well. So remember that since they are not mentioned, they're going to be held constant. So they're not changing, so they're not going to impact the pressure or the volume. So the next thing is the effect. So remember that our effect are just arrows. So for volume, we can see that at the initial and final, it goes down. So we have to figure out and look at the relationship between pressure and volume to figure out the effect it'll have on pressure. So remember, this is the only gas law relationship that is indirect. So if one goes up, so in this case, volume goes down, right, and pressure should go up, right? They do the opposite of each other. So we'll put our effect arrow there. All right, so now that we know the effect arrow for the pressure, that we should see it increase based on the relationship with volume, now we can go ahead and set it up. So remember, you always look at the effect arrow for what you're trying to solve for, so pressure. So because that arrow is pointing up, that tells us that the big number goes up top. So in my setup, you're going to start with your initial pressure, and we're going to set it up using dimensional analysis. So now big number up top, go to your volume, and we do 250, so that falls here, with 150 on the bottom. So when you do that calculation, you should get 1.6667 ATM. So remember, you still need sig fig, scientific notation, for your answer. Keep practicing that skill. So in this case, because your 1 atmosphere was technically not given in the problem, you were just told it was at standard pressure, and that's how we got here. You don't want to use that number for your sig figs. The numbers you're going to focus on are 250 and 150, which both have your 2 sig figs. So when we take our final answer, we can leave that decimal where it is. We're going to cut these off, so it becomes 1.7 times 10 to the 0, because we didn't move that decimal, atmospheres. And that's your final answer for number 1. Okay, so moving on to number 2. So the pressure in a bicycle tire is 7.144 ATM. Just going to fill in as I go. At 25 degrees Celsius, you take the bicycle, and then the temperature is now -5 degrees Celsius. What is the pressure? So I know I'm going to be looking for this. I'm going to cross out my volume and amount because they're constant. So I waited to put in my temperature values because remember, with gas laws, it has to be in Kelvin. That's the unit we need to use. So to each one, you need to add 273 to get your temperature into the appropriate unit. So when you do that, you should get 298 Kelvin here and 268. So we can clearly see that there is a decrease, so we put our effect arrow there. So the relationship we're looking at with this is pressure versus temperature. So this is a direct relationship. So based off of that, if temperature is going to go down, that means pressure is also going to go down. So now you can go ahead, just like we did on number 1, you can set up your calculation. We'll use our dimensional analysis. So again, use that effect arrow for the one that you're trying to calculate the final for. So it's for pressure. So the arrow is pointing down, so that means the larger number falls to the bottom. So 298 and then 268 Kelvin will go up top. And when you get this, calculator should spit something out similar to this. So that's just a calculator answer. So now again, go back to your sig figs, and for the initial pressure, this has 4 sig figs, and for both of your temperatures that are being used, this is 3 sig figs. So for the final answer, you always want to use the least number of sig figs. So we also need to move that decimal over, and then we only need 3 sig figs, so we'll cut our number there. You should get 5.71 times 10 to the 5th atmospheres. Okay, so on number 3, just go ahead, start reading the problem, fill out your chart. So a sample of gas occupies 150 liters at 25 degrees Celsius. What is the volume when the temperature is increased to 50 degrees? So pressure and amount are constant, so I'll just cross them out. We can now take, both of our temperatures, and you add 273 in order to get to Kelvin. So we should have 298 here, strange 8, and then 323 Kelvin here. And from that we can tell us that this is going to increase, right? And if you go back up to the problem, sometimes this can help too. If you reread, it does tell us that it's going to increase, so sometimes you can use that if you get confused with anything. So the relationship we're looking at is volume versus temperature. So this is also direct. So because temperature is increasing, we should see that increase in volume. So now we'll go ahead, set up, start with your initial of the unknown. That should be milliliters up there. So because of your arrow pointing up, that means the larger number should go up top. So we get 323 here, 298. So when you plug that in, your calculator answer should look something like this. So just calculator, right, not in sig figs. So my temperatures here have 3 sig figs, and my volume has 2. So my final answer always the least, so we want 2 sig figs. So I'm going to move that decimal as well, cut your number off there, and you should get 1.6 times 10 to the 2nd milliliters. Right, so now we'll just go ahead and move on to number 4. So go ahead, read through it, and you can start filling in your chart. So what would be the new volume? Put a question mark there. If 250 centimeters cubed of gas at 25 degrees Celsius with 730 millimeters mercury is your initial pressure, were changed to standard conditions of temperature and pressure. So remember, STP, the standard pressure we used earlier, 1 atmosphere, which in this case we already have millimeters mercury, so let's just go ahead and be consistent with that. So remember the conversion, if you go back to the top of this practice where all those notes are, 1 atmosphere is equal to 760 millimeters mercury, so we can go ahead and put that in our chart. That way we just don't have to convert the initial pressure into atmospheres, and this is a very simple You don't have to do math or anything to try and figure that out. So always keep it simple, and it doesn't say you're required to be in atmospheres, so you don't have to. Standard temperature, remember, is the 273 Kelvin, so 0 degrees Celsius. So we can put 273 here. We're starting with 25 degrees Celsius. So remember, just add 273 to that and you should get 298. Nothing was mentioned about amount, so we can go ahead and cross that out because it's constant. Now we can go in and we'll put our effect arrows. So for pressure, we can see that it's going to increase, and for temperature, it should go down. So notice that this problem is a little different because now we have pressure acting on volume and affecting it, and we have temperature doing the same thing. So in this example, go ahead and put a line through your effect for volume because now we have to have two effect arrows. So that's what we're going to see here, our two effect arrows. So you have to look at these two relationships. So pressure versus volume, which is indirect, versus our volume and temperature, which is a direct relationship. So based off of my pressure and volume relationship, and I always label it here so I can keep track of my arrows as well. So pressure versus volume, if my pressure is going to go up, then my volume should decrease. And now we can look at our volume versus temperature. So my temperature is going down. They have a direct relationship. So again, we should see that decrease in our volume. So now we focus on the effect arrows for the one that we're trying to solve for, and we just set up our conversion, our calculation like we have. So start with your given volume. Okay, and this time now you're going to have two steps. And don't do it step by step, just do it all out and calculate it all together. You don't need to get the number in between and then use that. Okay, so it doesn't matter if you use your pressure numbers or temperature numbers first. I'm just going to go with pressure because that's what I feel like. Again, it doesn't matter, no matter what, as long as you set it up correctly based on your effect arrows, we're all going to get the same answer. So because both of my effect arrows here are pointing down, that means my large number for both variables is going to fall to the bottom. So we'll put our 730 up here, and then for temperature, 298 below, and 273 is going to be up top. So when you plug this all into your calculator, you should get, just as your calculator answer, something very similar to this, 219.986. So now let's go look at our numbers, look at our sig figs. So this guy, 2 sig figs, same with these, and then here we see 3 sig figs. So always the least number, so in this case it's going to be 2. So when we move our decimal over, and then 1, 2, we'll cut it off there. So you should get 2.2 times 10 to the second centimeters cubed as your final volume. Right, and now on to number 5. So again, read through and just start filling in your chart, always the first step. So Sam's bike tire contains 15 moles. So remember, N represents the amount, and it's always going to be in moles. Has a volume of 160. Under these conditions, our pressure is 13 psi. Develops a leak and 5 moles escape. So it's not saying it decreases to 5, it's saying that 5 escape. So just take 15 minus 5, and so the final amount is going to be 10 moles. And now the last part, the volume contracts to 150. What would the tire pressure be now? So temperature is going to be held constant. And again, we now see two relationships that we have to take into account. So the relationship between pressure and volume, which is indirect, and then the relationship between amount and pressure. Okay, so our effect arrow for the amount, it decreases, right? It lost 5 moles of gas. And then the volume also got smaller, so we'll put our down arrows. Now for this last one, remember, you have to have two effect arrows to represent both relationships. Okay, so pressure versus volume is indirect. My volume is going down, therefore pressure should increase. And now your pressure versus amount, the less moles you have, the less collision, so the less pressure, so it should show a bit of a decrease. So this one you still just do it all in one step. So start with your 13 psi, and we're going to have the two steps here all together. So we'll just do the pressure versus volume arrow. So since it's pointing up, that means my big number for volume falls to the top, so 150 goes here. Now for the amount, for the moles, that effect arrow points down, so 15 is going to fall to the bottom and 10 will fall up top. So when you plug this into your calculator, you should get a number 9.244 psi. Now let's go back, look at our sig figs. So we see two sig figs here. Both of these numbers also have two sig figs. Here's our one sig fig, and 15 has two sig figs. So least number is going to be one sig fig. So we don't have to move our decimal. We're just going to cut this off there. And now we should get 9 times 10 to the 0, again because we did not move that decimal. So I know with this one, our effect arrows, it says that pressure should increase, but it also says that pressure should decrease. So if you were to do this step by step, so let's say we actually found what the number would be after we calculated with volume, it'd be about 13.9 psi. So according to the relationship, right, it said pressure should go up based on the volume, which in fact it did, but because of the amount of moles in that relationship, when we go that one step further, that's why we get this number, which in fact fits with that arrow that we see the decrease. So, and it's all just one fluid motion. That's why we don't do it this step by step, because in reality, as this is happening, that pressure might go up, but it's going to come down because of the moles that are leaving. So don't let that trip you up. Just do it all out in one step, just like we've done before. All right, on to the next one, number 6. So a closed flask of air, which is 2.50 liters of volume, contains 5 moles. Pressure reads 93 kilopascals. So we are going to add an additional 3 moles. So again, pay attention to your wording, right? It doesn't mean we have 3 moles. It says we're adding 3. So now we should have 8.0. Keep the sig figs to match that 5. Find the new pressure inside the flask. So put a question mark there. So if you notice in this problem, it gave you that volume of the container, but it didn't mention it again. It didn't mention that it was changing. So in reality, it was just extra information, and volume is just held constant, just like the temperature. Okay, so from there we'll fill in our effect arrows. So with the amount, we know that we added particles, so we should see an increase. And then we have to look at our relationship between the pressure and the amount. So it is direct, right? The more particles that you have, means the more collisions and all that kind of thing. So that means more pressure. So we should see an increase. So now just go ahead, start with your initial pressure and set up. In this case, it's only just a one step because the amount of moles is the only thing acting on the pressure. So according to our effect arrow pointing up, that means that the larger number for the amount is going to go to the top. So your setup should look like that. When you plug it in, you get 148.8 kilopascals. So now go back, it says 2 sig figs, and both of these numbers also have 2 sig figs. So final answer is going to need 2 sig figs. We're also going to move the decimal and then 2 sig figs, cut it off there. So it becomes 1.5 times 10 to the second kilopascal as your final answer for number 6. So now on to number 7. So read through, fill out the table. So a 350 milliliter sample of gas at a temperature of 30 degrees Celsius and a pressure of 1.20 atm. What temperature would be needed for the same amount of gas to fit into a 250 milliliter flask at standard pressure? So it tells us that the amount of gas is constant, so you can cross that out. And then standard pressure. So remember, if you need to, go way back up, first page, those notes to remind yourself. It is 1 atmosphere. And now we need to convert temperature right into Kelvin. So when you do that addition, your initial temperature should be 303 Kelvin. And now let's do our effect arrows. So for pressure, we see a decrease. Volume, we also see a decrease. So we're back to the problem where we've got 2 variables acting on 1. So we need to look at 2 relationships. So pressure versus temperature and volume versus temperature. So both of these are actually direct. Higher the temperature means more movement, which means more pressure. And for volume, again, higher the temperature means more movement. So because those particles have more energy, the volume is going to expand. So kind of like a balloon going from room temperature outside in Texas heat can sometimes even pop. So now we'll focus the effect arrows for our temperatures. So we'll do the pressure versus temperature and then volume versus temperature. So since they're both direct, pressure is going down, therefore so should temperature, and volume is going down, so temperature should go down based on that relationship. So now you can go ahead, set up your calculation. You are going to need 2 steps here. Okay, both arrows are pointing down for your effect, so that means big numbers for both sets should fall to the bottom. So 1.2 goes here, put 1 atmosphere up here, and then 350 milliliters there, 250 up top. So when you do that calculation, you should get something around 180.357 Kelvin. So it did, in fact, it went down pretty decent amount. So now final things, look at your sig figs. So we've got 3 sig figs from our temperature. Both volume numbers have 2 sig figs, and the pressure has 2 sig figs. So remember that the 1 atmosphere is a constant. You weren't given that in the problem. You were just told it was at this standard pressure. So never use that as a defining factor for your sig figs. So for us, we're going to use 2 sig figs in our final answer. So we'll move our decimal over 2 places, count 1, 2 sig figs, and cut that off. So you get 1.8 times 10 to the second Kelvin. Now moving on to our last problem in the guided practice. So a 475, centimeters cubed sample of gas at standard temperature, 273. Remember, that's something we have to know. Can revisit it at the very first page with all the notes. And standard pressure, so 1 atmosphere, is allowed to expand until it occupies a volume of 600 centimeters cubed. What temperature, so we'll put our question mark there, would be needed to maintain that standard pressure? So when it says maintain, that means pressure actually isn't going to change. So it's held constant, so it's not going to affect our temperature. So we can actually just go ahead and cross it out. If you used the pressure with the 1 atmosphere over 1 atmosphere, it doesn't matter because 1 over 1 is 1 and anything times 1 is the same. So even if you included that in your calculation, you're still going to get the same answer. Okay, so we can see that our volume increased. So we got to look at our relationship between volume and temperature, which is direct, right? We just talked about the hotter things are, the particles have more energy, so they move more, so they're going to expand like they would in a balloon. So because volume is increasing, that means the temperature should also increase, because we also want to maintain that pressure of 1 atmosphere. So we'll go ahead, set up your calculation. Okay, according to my effect arrow, the large number should go up top, so that's 600, with 475 on the bottom. When you do this math, you should get, as a calculator answer, 344.842, give or take some decimals. So now go back, revisit sig figs. So both of these numbers have 3 sig figs, and this volume has 4. So we want least number, so we're going to go with that one. So now we will move our decimal over, and we only need 3 sig figs, so we're going to cut our number off there, and you get 3.45 times 10 to the second Kelvin as your final answer. So that is all of the problems on that guided practice over the PVnT charts. This is on your quiz on Thursday, so make sure you revisit any that you had trouble with. You don't have to watch all of these. Let your teacher know if you have any questions. You can use Microsoft Teams. Remember, we have the required class time, so make sure you show up, ask questions. I know I'll be reviewing this stuff as we prepare for our quiz as well. Alright guys, well, thanks for taking the time. So we've got about 3 weeks left with all of our online stuff. I hope everybody's doing well. I think we're doing a great job at most. I think everybody is doing what they need to be doing. I know this is difficult with all the online stuff. It gets challenging because you don't have that one-on-one time. So I hope you're doing okay. If you need anything, just let your teachers know, counselors know. We're all kind of in the same boat. So have a good week.